Now I'm going to show you how starter motors work. A lot different than alternators. They're designed for high output torque and to spin at a lower RPM, and they have a solenoid which engages the drive gear, which engages the flywheel. So there's a typical General Motors starter motor like they've been making for 50 years. This one's from a Toyota, but it's also very common nowadays in Chryslers. The same company makes them for Chrysler. So I'll explain the problems that they have and how to fix them if you have a Chrysler vehicle, a Toyota, or a Honda that may use this type. So first, this General Motors starter, since all the old-timers like me know them so well. Well, that's the solenoid. There's your motor body, the nose, and there's where the drive gear comes out. Once you remove the two screws, you can take the back screw off. You can get the solenoid apart. The solenoid consists of a electromagnetic coil around a steel pipe, a return spring, a plunger, and a lever. When the solenoid is energized with 12 volts, it sucks this plunger in all the way to the bottom like that, and when it does that, it pivots this lever. So this is the armature, the part that spins. There's your solenoid plunger, and when it's engaged, pivots that lever and moves the drive gear in and out so it can engage the flywheel. Now inside the solenoid is a spring-loaded button at the bottom, that little round dot. When the plunger piston is fully sucked in by magnetism, it pushes on that shiny spot, depresses that plunger, and in the back part here it pushes on a big copper washer which makes two connections to the two big bolts. Each big bolt has like a little copper engagement plate or a contactor plate that the washer goes against, so there'll be one there and one there. These things get worn down. I'll show you what I mean on this Toyota starter, or Chrysler starter if you want to call it that. There's your copper washer. On this model it's attached to the plunger, and inside the solenoid housing is two of these contactor plates. You can see the worn mark as they wear down, little sparks erode them. Once they get a big enough step on the edge there, then the solenoid just starts to make clicking sounds now and then, and only occasionally engages. Then all you got to do is spend like $2 or $3 a piece, buy two of these, unbolt them, replace them, sand and clean the copper washer a little bit, and reassemble. So many of you guys have had Chrysler starter motors and had to replace them when you only had to spend $5 to fix them, or Toyota starter motors, or Honda starter motors. It's just so simple to remove those two little contactors, replace them, clean this, put the tiniest bit of lube on there, and your starter motor will work brand new, like brand new for years. So the drive gear that turns the flywheel is called a Bendix. It's called a Bendix because some guy in the 1920s invented it. It's just got a one-way clutch in here. The gear can freewheel like I'm doing now. I can turn it backwards, but it's not turning the armature. But if I turn it this way, it drives everything, and that's so that when the vehicle starts, the flywheel, which is about 50 times bigger, doesn't start spinning it like at way too high a speed and cause your armature to over rev and cause all the windings to explode and blow up by centrifugal force. Sometimes when you turn your key and you hear your engine just going whee, I mean your starter motor doing that and not engaging, it probably is coming out and engaging, but the grease inside the Bendix dries up or leaks out, and it causes it not to engage, especially on cold days. So then all you got to do is buy another one of these gears. They cost anywhere from $10 to $50 depending on what kind of vehicle. A redneck solution to repairing one of these Bendix gears that's slipping is to drill a tiny hole right near the center, about 1/8 of an inch diameter if it's possible, and get a can of Castrol chain lube for motorcycles and spray that in there. When the chain lube dries up, it gets very sticky. That will recreate friction within the roller bearings in there and cause the gear to re-engage again and not slip. It doesn't work every time, but Sometimes you don't want to buy a new starter motor or a new gear if you're getting rid of the car soon. Here's a mostly assembled starter motor, and I'm going to pull the lever we were talking about moments ago. It's inside this housing. You can see how the starter engages every time the solenoid engages. Common problems with almost all starter motors is bad bearings in there or bad bearings in the other end. If you take your armature out and look at it, you can sometimes see if the bearing surface is good, but usually the steel part's okay. It's the soft bronze bushing in there that goes bad, and they're easily replaced. Another way to know that they're bad is if you see the shiny spots like you see on this armature. That means the armature is moving sideways because of the worn out bearing, and the magnetism is sucking it into the field magnets, and it's rubbing and causing a lot of friction, and then when you go to start your vehicle it goes wow, wow, even if your battery's good. If you take your starter apart, check to make sure the commutator is in good condition. When you reassemble it, always put some sort of grease on both ends in those bearings. Never get grease on the commutator or fingerprints. Inside the body of that starter motor, and pretty much all other ones, is a set of field magnets. You can sort of see them. Most starter motors have 4 of them, and most electric motors only have 2. The reason starter motors have 4 is because then it has double the magnetism. That gives it double the torque. Another really common reason why starter motors go whir, whir, and crank really slow if the bearings are good and nothing seized is that the field magnets get burned out. They burn out a lot more often than anything burns out in the armature. So that's called an overdrawing starter motor. And these field coils usually burn out as if one time your car didn't start and you were just cranking it too long. That overheats them, and it causes the wrapped up windings in there to fuse together and draw too many amps. And on the other end is the brushes. Most electric motors just have 2 sets of brushes, that rub on the commutator, except that starter motors often have 4 sets or 4 brushes, and that's because there's 4 poles on the field. And the reason for this is, of course, double torque. That's a very common problem, is the brushes are worn out. If you've got a starter motor that works on some days and on other days just goes click, very often just give it one good whack with a hammer and it'll come back to life temporarily, because as these brushes get worn, they're barely touching the commutator, and a little whack causes them to move over just a bit, and you can start your car a few more times. On these kind of starter motors that Toyota uses and Chrysler uses and Honda uses, on Chryslers they sit very low, especially if you have a V6 engine. Well, the problem is if you go through deep water or take your vehicle mudding, often a little bit of water gets inside here in the body that contains, the solenoid plunger. Well, what happens is after the vehicle sits for a few days, some rust forms on the plunger, and when you go to turn your key you don't hear a sound because the plunger is not being sucked in and engaged. Another place rust forms is on this little conical shaped thing, and it rusts itself to the conical hole, so that becomes stuck to that and doesn't get sucked in. It doesn't make a sound. Just remove the 3 screws, just break this off, put a tiny bit of grease there, make sure you get none on the copper washer, sand this area clean a little bit, put a very light layer of grease or oil there, and you've repaired it again without replacing any parts or spending any money. Right, Katie? These kind of starters are a gear reduction starter, so they have a smaller motor as they need less torque with gear reduction. So that means they have a small gear on the output of the motor and a larger gear up here that drives the Bendix. When the solenoid plunger is sucked in and engaged, I'll show you what happens. Now I'm going to push that plunger, and you see on this end it engages the drive gear to the flywheel. And it also has a Bendix on the end, just like the other starter motor does. Now in this video I haven't mentioned the older style Ford starter motors. They don't have a solenoid sort of like these things do. They have an opening in the body of the starter motor and a magnetic plunger which is part of the field assembly of the starter motor. So when you turn the key, magnetism sucks in the magnetic part of the field magnet, and that's hooked to a lever which moves this thing back and forth to engage the drive gear. It's actually a very ingenious design, And I've got a simple redneck technique to fix them too when they're not engaging. One more problem encountered with starter motors is when you turn the key, you don't hear anything happen, or sometimes you hear the click and nothing else you do will make it engage or make it start cranking. Well, on starter motors on many starter motors you have an aluminum nose and a steel body. Well, salt water gets in between the two housings and causes electrolysis, and there's corrosion forms in between there. So there's a redneck repair for that too without removing the starter motor. This is really common on old Tempos and Topazes and a lot of Fords. All you do is drill a couple little 1/8 holes wherever you can get access to the starter motor while underneath the car with it installed. And then you just get a couple sheet metal screws and screw them into those 1/8 holes. And that will cause this body to ground to that body, and it'll be a temporary fix to get your starter going. So to sum it all up, if your starter motor cranks slow and seems to draw too much power, could be burned out or shorted field windings, or bad bearings on either end. If it has a dead spot in it, which means if you rotate the starter a little bit by hand or screw around with it, and all of a sudden it comes back to life again, means you've got a bad pole in your armature. If you've got a bead on your starter motor with a hammer to get it to work sometimes, it either means you've got a bad contactor, a sticking plunger, or worn out brushes that are barely touching the commutator. And if your starter motor makes a whining sound and doesn't engage and turn the motor, it usually means you need to replace the Bendix or somehow get some sort of sticky grease inside there. And if you hear no sound at all when you turn the key, it often means the plunger's stuck from rust, or the plunger won't be moving because the brushes aren't contacting the commutator properly, and the solenoid actually grounds out through the armature, through the commutator to ground. So if you don't have a good connection on here, the solenoid actually won't engage. Pretty simple in my books. And you know you're a redneck when you start taking starter motors apart on your kitchen table. Cool.